Hello everyone, welcome to this video. In this video, we're going to discuss fundamental counting principle. And the principle were the sources from grade 10 mathematics, patterns, and practicalities. In a compound event, which the first event may occur in n sub 1 different ways, and then the second event may occur in n sub 2 different ways, and so on. And the kth event or in any event may occur in n sub k different ways. The total number of ways of the compound event may occur in multiplying the different ways from the first event going to the k event. Let's have an example. In a student council election, there were four candidates for president, three candidates for vice president, three candidates for secretary, and four candidates for treasurer. The question is, in how many ways can this position be filled? Let's have the principle. So if there are any ways that we could work out. So as you can see, the first one is four candidates for president. The second one is three candidates for vice president, three candidates for secretary, and four candidates for treasurer. Each blank represents the position. The first blank would be for the president. This is for the vice president. This is for the secretary, and this is for the treasurer. Now let's have some answer. So how many ways the for the president? How many selection for the president? So there are four, and then for the vice president, there are three, and then for the secretary, there are three as well, and then for the treasurer, there will be four. So we need to multiply this one. 4 times 3 times 3 times 4. So the answer is 144. And that's how the principal counting was used in this problem. Let's have another example. A particular type of combination lock uses the digits 0 to 9. How many sequences of three numbers can be formed to open the lock? Okay. So in analysis, you have now 0 to 9. So therefore, you have 10 choices such as 0, 1, 2, 3 until 9. How many sequence of three numbers can be formed? So there are three numbers which is represented by the blanks. So when we write that as our answer, we could say that on the first blank, you can have now 10 digit that you could choose, another 10 digit here, and another 10 digit here that you can choose. So you multiply 10 times 10 times 10. So there are 1,000 number of lock combination that could open now this lock. Let's have this example. How many four-letter codes can be formed with the letters M, N, O, P, Q, R, and S with repetition? So it means that you can repeat now the letters in the code. So technically, you need to have four blanks to get the number of four-letter codes. So let's count now the number of letters. So we have 1, 2, 3, 4, 5, 6, 7. So we have now 7. So technically, we have now 7 letters. So you can choose from the first letter for the code is 7, another 7 here, and another 7 here, and another 7. So you can now add now no, technically not add, but you can multiply now 7 times 7 times 7 times 7. So the answer would be 2,401, if I'm mistaken. 2,401 codes could be created using the 7 letters such as M, N, O, P, Q, R, and S. Let's have another problem. So the problem is almost the same with example number 3. However, here without repetition. So it is not allowed that the repetition going to happen with that. So how are we going to do that? Technically, you still have, You still have the four blanks. However, we know that we have seven letters. So on the first blank, I believe we could write there seven. And then here is six because you cannot repeat what you chosen. So if repetition is not allowed, you deduct one. And then here you cannot repeat. So that would be five. Deduct one from the choices. And this would be 4. So you multiply now the four numbers, 7 times 6 times 5 times 4. So the answer would be 840 codes could be created. I hope you learned something about fundamental counting principle. And that's how we multiply the number of possible ways in each of the independent events that's happening. Hope you learned something with this video. Thank you very much for watching. Have a great day.